everyone. Today we're diving into the basics of sets and fascinating world of real numbers. Let's get started. First, what is set? To simply put, it is a collection of distinct objects wherein we use curly bracket to denote set.
For example, the set of fruits is equal to apple, banana, and cherry.
Set relations describes a connection or relationship between elements of one or more sets. Under set relations, we have subsets and proper subsets. A subset is the set of all elements that are also in the other set. For instance, let set A 1, 2, set B 1, 2, 3, and set C 1, 2, where A is a subset of B and A is also a subset of C. A proper subset is a set where every element of A is also an element of B. Think of a proper subset as a smaller part of something in which it is a subset but not equal to the larger set. For instance, let set A 1, 2 and set B 1, 2, 3 and set C 1, 2 where A is a proper subset of B but A is not a proper subset of C. Set operations consist of 5 ways to combine 2 or more sets into a single set. Union sets. Union sets are the sets of all elements that are in A or in B, wherein all elements are combined. For example, with the given set A 1, 2, 3, set B 2, 4, the union of A and B is 1, 2, 3, 4. Intersection. Intersection sets are the sets of all elements that are common to A and B. It is a set that contains elements that are both in A and B. With the given set A 1, 2, 3 and given set B 2, 4, the intersection of A and B is 2 only. Difference of two sets. The difference of two sets are elements which belong to A but does not belong to B. Simply put, what is found in A that cannot be found in B. For example, with a given set A 1, 2, 3 and set B 2, 4, A minus B is 1 and 3.
The complement of a set are elements of a universal set that are not found in A, which is similar to the concept of difference of two sets. To simply put, what is found in a universal set that cannot be found in A? For example, with a given universal set of 0, 1, 2, 3, 4, and 5, and the set of A which consists of elements of 1, 2, and 3, where the complement of A has elements of 0, 4, and 5.
The Cartesian product is denoted as A times B. It is a set of all ordered pairs x and y, where x is in set A and y is in set B. For example, with a given A equals 1, 2, 3 and B equals 2 and 4, the Cartesian product of A and B is 1, 2, 1, 4, 2, 2, 2, 4, 3, 2, and 3, 4. Now let us explore the sets of real numbers. The real numbers are denoted by R, wherein it is a vast collection that includes everything on the number line. Rational numbers are presented in P over Q, where P and Q are integers and Q does not equal to 0. Examples include 1/2 and negative 3/4. Non-integers are those numbers expressed in decimals or in fractions. A non-integer can be expressed in decimal form, which can be terminating, like 0.5 and 0.25. It can also be expressed in non-terminating but repeating decimals, such as 0.333 and 0.166. Non-integers can also be expressed in fractional form, such as 1/3 and 1 over 8.
Another subset of rational numbers are integers, that consist of positive integers and negative integers. So, within integers, we have natural numbers, which are also known as the counting numbers. For example, 1, 2, 3, 4, and so on. But now, if you include 0 with the natural numbers, it will form the whole numbers. Instead of counting from 1 to 3, you count from 0, 1, 2, 3, and so on. Of course, integers aren't only limited with non-negative integers. In fact, it has negative integers as well. Negative integers are basically integers that are less than 0. For example, -1, -2, -3, and so on. Under real numbers, we have irrational numbers denoted as Q prime, wherein numbers aren't presented in the form of P over Q. Rational numbers are always non-terminating and non-repeating. For example, pi, Euler's number, the square root of 2, square root of 3, and 0.242868, and so on. And with that, you now understand the basics of sets and the sets of real numbers. Thank you.